All right, everybody. So first question that might come up is, why are we starting with section 1-3? Because there's a lot of repetition in 1-1 and 1-2 from things that you've already done for 2 years in other math classes. So we're just going to move ahead a little bit and not waste time on those pieces. They're things you already know how to do, and we know that from years and years of teaching this course. So it's Mrs. Cedarholm again, and this is Algebra 2, Lesson 1-3. Notice that each one of these sections is going to have an objective. Our objectives here are to evaluate algebraic expressions and to simplify algebraic expressions. And I'm going to need everybody to grab those yellow lesson objective sheets that you were given. And it says Algebra 2, Chapter 1, name an hour. And then you see all the wonderful standards that the state has from the material that we're going to cover in Chapter 1. And then you turn it over and you see concept 1-3. I can evaluate algebraic expressions. Well, look at that. It matches this one right here. And then the next one you see is I can simplify algebraic expressions. Now the example in the description part, that's something you could use if you need some extra review at the end of the unit. But what I need you to do before we start this is your rating before the lesson. And you need to use the 4-3-2-1-0 scale that we have up at the front of the classroom in your math classes. And 4 is I can teach someone else this learning target. So this is easy for me. I know what I'm doing. I could go up there and do what Cedarholm's doing today. Number 3, I can complete practice problems of this learning target on my own. If somebody asks me a tough question, I might not be able to teach that to them, but I can certainly complete all of the problems they have here. Number 2, I can complete practice problems of this learning target with minimal assistance. Yeah, you know, if it's a hard word problem, I might need somebody to help me out with that. And then we've got number 1, which is I can start the practice problems of this learning target, but can't finish them. So maybe you can do the first 5, but after that, you're looking at it, looks a little bit tough. And then the very last one there, 0, even with assistance, I can't complete problems for this learning target. So this would be, you're looking at it and you're saying to yourself, I don't remember anybody ever talking to me about algebraic expressions. I think I must have slept through that lesson when I learned it before, and yeah, I can't do it. So rate yourself before the lesson. And then put that in your binder or your folder or wherever, because you have to come back to that. Notice that it says rating after the lesson. So when I finish the lesson, which will be tomorrow's video, then rate yourself after. And the hope is that you'll all be 4s. And I realize some of you will probably put a 3 down just because you didn't want to teach it to somebody else, but I hope you'll all be 4s or feeling like you're 4s after that. And then after you do the homework, rating after the homework, then everybody should be 4s. All right? So you know exactly what you're doing and you know how this is going to work. So let's put that yellow sheet away. Grab your note packets. And your note packets for this chapter had an ivory, I guess kind of a light tan, first page on them that's labeled 1-3. And those are the objectives that, again, at the end of the lesson, you want to say, oh, yeah, I think I got that. I know how to evaluate and simplify algebraic expressions. So in past years, we could have partners work on this. We're going to kind of think about this together in class. And it says, discuss the following vocabulary with your partner. So think a minute about the word evaluate. If a problem says evaluate, and then they give you an algebraic expression, what does that mean you're supposed to do? To help you out a little bit, let's say they give you 2x plus 3y equals something. And then they come along and they say x equals 2 and y equals 7. Think about what you would do if it said evaluate the algebraic expression 2x plus 3y if x equals 2 and y equals 7. So evaluate means substituting a number for a variable. You take the numbers that you have for x and y, the 2 and the 7, and you put them in there, 2 and 7 for x and y, respectively. So 2 goes right here, and 7 goes right there. And then we have to remember that when things are sitting right next to each other in algebra, that means that we're multiplying. So 2 times 2 plus 3 times 7. And then you'd follow the order of operations. Please excuse my dear Aunt Sally. And you would multiply first. 2 times 2 is 4. And 3 times 7 is 21. And then you'd add 4 plus 21 is 25. So you're finding the value of an expression when you evaluate. So notice what's in the box here is what you should be writing in your notes. I want you to also notice that there are lines on the side over there. You know, on the right-hand side of the margin, you're going to see lines. Lines are where I want you to write those light bulb moments, the moment you go, oh my gosh, I totally get it now. What was it that I said? Or what was it that a partner said? Somebody in class said that made you go, oh, this totally makes sense. Or maybe you're looking over your homework and you're thinking, gosh, this part right here, I'm not getting it. And you go back into your notes, and I want you to write, I should ask about this. You know, what do I need to ask about as we go through these things? So those are the kind of things that go over on those lines. Aha moments, I've got it, and questions, things that you need to ask about. Next vocabulary piece, term. What is a term? So I want you to go back to this and think, what's a term? Well, 2x is a term. 3y is a term. So that has two terms. It has 2x and 3y, because a term is an expression that is a number and or variable or variables, or the product of them both, because again, they're sitting right next to each other. So go ahead and write that in your notes. The big deal here is that to tell what the terms are, it has to be addition. So if we see something like this, 5x minus 4y, we would change that to 5x plus a negative 4y. Now, why do we have to make that change? Because if we're asked for a term, terms are always separated with addition. So that one would have two terms. The first term would be a 5x, and the second term would be a negative 4y. Terms are always described with addition. So an expression that is a number and or variable or variables, product of them both, 5 times x is 5x. A coefficient. What do you think coefficient is? So this one's kind of hard because, you know, you try to break it down like words are supposed to be broken down, and co means you've got a couple of things working together. Coefficient, working together efficiently. Well, the coefficients are the numbers in front of the terms. So, fancy language, the numerical factor of a term. 2x. The coefficient is 2. Negative 4y. The coefficient is negative 4. So, the number in the term. Now, constant term. Think about that one for a second. What is a constant term? Well, constant means something that's not changing. Variables vary. That's their root word. So it can't have a variable, but it has to be a term. So a constant is a term with no variables. Maybe it's 5x plus 3y plus 8. 8 doesn't have a variable. So it's the constant. It can't change. It's 8, no matter what. And there it is. Like terms. Like terms. Usually people can tell me if I give them an expression like the one that you see here in the red, they can tell me what they need to do, but how do you say that? You know, how do you make a sentence that explains what like terms are? Well, look at the two things you want to put together. What could you tell somebody about those two terms? Like terms are terms that have the same variable raised to exactly the same power. Now, we probably should put same variables, because as you see in what we have in the red here, it is possible that you can have 2 or more variables on each of these. So 3x squared plus 2xy minus 5x plus 7xy minus 9x squared minus a negative 3x plus 10. So what we need to do here is first notice that we have minus a negative in one of these terms. Minus a negative becomes addition. So we should write down that step, acknowledging that we know that minus a negative is a plus. So how are you going to earn points in this class? If you provide a step that takes you closer to the solution, you're going to earn points. It has to be the right one, and you, of course, have to do it correctly. Now I look around and I see terms that have the same variables raised to the same power. So I have a 3x squared here. And if it has to have the same variable to the same power, I need another x squared. And that's going to be right there. And 3x squared minus 9x squared would be a negative 6x squared. Let me see, I'm going to come up here a little bit because I write real big. So now I have my x squareds taken care of, and I go to the next term, and I see the next term is 2xy. So I'm looking for other xy's, and I see plus 2xy plus 7xy, because you always go by the sign that's in front of the term. And if there isn't one, like this one up here, it's because it's positive. 2xy plus 7xy is 9xy. Next term, negative 5x. Well, there's the other x to the first term. So negative 5x, oh, and that was a plus that I erased there. There we go, because minus a negative is a plus. So negative 5x plus 3x would be a negative 2x. And I see the only thing I have left here, because I already did the x squareds, I already did the xy's, I already did the x to the first, is a constant, plus 10. No variable sitting there all by itself. Now, I used colors and symbols to show the like terms as I went through here. Usually if somebody gets this wrong, it's because they lose track of something, you know? So let's just say I did shapes. We've got a line, we've got a rectangle, we've got a circle, and then maybe I do a double underline on my 10. But what I'm making sure of is that I have collected all the like terms together that I possibly could. So I look at my answer, got an x squared, an xy term, an x term, and a constant. Yep. None of those could be put together. I'm done. Now, we need to go back to thinking in terms of words. How do people describe these if they want us to change this into algebra? Problem 1 says, which algebraic expression models the word phrase 7 fewer than a number t? Fewer than. Does that mean less than? Let me think here. 7 fewer than a number t. Okay, I'm looking at all those answers. It's not less than. So am I supposed to take 7 and subtract t? Or am I supposed to take t and subtract 7? Well, let's read through it and see. 7 fewer, oh, so I'm going to have to subtract 7 from something. Then a number t. Well, it's t. T is what I have to start with, and I'm supposed to do 7 fewer than that. That's t minus 7. That's answer C. Now, this is one that it's pretty common for people to go too fast and put 7 minus t down on that. Be careful when you're reading through those. You know what to do. Just take your time. Try the got it on your own. Which algebraic expression models the word phrase 2 times the sum of A and B? So let's see what you've got. 2 times the sum of A and B. Okay, 2 times. That's pretty easy. 2 and multiplication. Sum. Sum of A and B. What does sum mean? Oh yeah, sum means total. So if I put A plus B and get a total, then I'm going to take 2 times that. Oh, this is answer C. And there it is. So we just did some translating. We took words and translated those into algebra. Let's look a little bit tougher. To model a situation using an algebraic expression. So these bullets are going to give us hints. How do we do that? How do we read it and change it into algebra? Well, what we have to do is identify the actions that suggest operations. What does times mean? Times means multiply. What does sum mean? It means total. What does product mean? It means multiply. What does quotient mean? It means divide. You know, all of those words that we've probably had a few months here to forget that we need to know. We need to know what operation is suggested. And our operations are the, please excuse my dear Aunt Sally. Then we want to define one or more variables to represent the unknown. Which of these could vary? Which one should be the variable? Represent the actions using the variables and the operations. Put together what you know about sum of 2 unknowns, A plus B. Problem 2. You're on a bicycle trip. You traveled 52 miles the first day. Since then, your average rate has been 12 miles per hour. What algebraic expression models the distance you traveled so far? All right, think of that. Think about that for a minute. So, they want me to model, I'm going to start at the end here, model the distance that I've traveled. Oh, well, they said 52 miles. But was it just 52 miles and you stopped? No. Because after that, since then, your average rate has been 12 miles per hour. Oh, they're talking about distance and rate? Wait a second. I think there's a little formula we've used for that before. Distance equals rate times time. So if I want to have the answer about distance, I'm going to have to think about rate times time. Average rate of 12, so I'm going to have to add 12, but not just 12, miles per hour. That's a rate. So this 12 is going to happen every what? Every hour. Oh, I don't need those parentheses. Because I know that in algebra, when 2 things sit right next to each other, that's multiplication. So 52 plus 12h. Now, we probably want to tell somebody h equals hours. And in those steps it said, define what your variable stands for. What is that going to be standing for? I want you to try the got it. Read through it. check with somebody close to you, to the side, behind you. Check and see if they have the same thing. You had $150, but you are spending $2 each day. What algebraic expression models this situation? Okay, so let's see. I had 150 bucks. Ooh, I'm spending. Well, then that's not adding. When you're spending money, it's gone. It's being taken away from you. So minus $2. But is it just $2? And the answer is no, because it said $2 each day. So $2 for every day. And then I realized I probably better put over here D equals days. So people will know exactly why I set everything up the way that I did. Order of operations. Mentioned that earlier. Some of you have learned the please excuse my dear Aunt Sally. Occasionally, that messes somebody up. What you need to remember is P, parentheses, grouping symbols. Do those first. E, exponents. Anything being raised to a power? Got to take care of that next. M is multiply from left to right. D, divide from left to right. Add and subtract, same thing. From left to right. It does not mean that multiplication always comes before division does. It does not mean that addition always comes before subtraction does. We multiply and divide. These two are grouped together, left to right. And we add and subtract. Those two are grouped together from left to right. So now I kind of get the feeling like I'm switching gears here. So I look at my objective and I realize that when we went through those objectives, let me pop that back up here, and it's in your packet too. It said to evaluate algebraic expressions and to simplify algebraic expressions. Well, I feel like so far what I've been doing isn't really, one of those. What I've been doing is taking words and translating those into math, into algebra. So, problem 3 finally brings us to one of those objectives. We want to evaluate. And problem 3 says, what is the value of an expression for the given values of the variables? So, there's our algebraic expression. And then it says, for a equals -4 and b equals 5. Well, that means we're supposed to substitute -4 in for a anywhere that we see it. And we're also supposed to substitute 5 in for b anywhere that we see it. So what I've done is I've left the spaces here where I see an a and a b. And a is -4 now. They told us that. And b is 5. So now what? Well, on the front of the packet, we said evaluate is you put the numbers in and then you follow the order of operations to get an answer. Okay, so I've got it in there. I substituted those in. P, parentheses. Oh, yep. I see a set of parentheses right here. There it is. -4 plus 4. Oh, I know that one. That's 0. Now, there's also parentheses there at the 3 and the 5. But we're not doing anything inside the parentheses. It's already been simplified in there. So that's not because of parentheses. It's just a placeholder so that I know I'm supposed to multiply. But before I do that, I check the next step. Please excuse. Oh, exponents. Hey, this one doesn't have any exponents, so I don't have to do that. Multiply and divide from left to right. Well, that I can do. 7 times 0 is 0. Plus 3 times 5 is 15. And then we have a -8 in the back. All right, almost done. That was multiply and divide. Now I'm down to, please excuse my dear Aunt Sally. Add and subtract left to right. 0 plus 15. It's 15. 15 minus 8 is 7. Hey, that was one of our objectives, being able to evaluate. So 7 is the answer. Now, this one is a little tougher. It looks a little more complicated. We have x over 2, which means division. That's a quotient, division, plus y squared for x equals 1 and y equals 1/2. So here's my algebraic expression right there. And I don't know if those little lines came through on your note packet. It doesn't look like it. We don't mean absolute value. That might mess with you a little bit. It just kind of copies weird when we do those on the smartboard. So we need to substitute an x of 1. And we need to substitute a y of 1/2. Let's not forget our equals. Whenever you're working in math and you go to the next step, y, what were you trying to do? And what we're trying to do here is just put the numbers in, not change anything yet, and evaluate. All right. So, please excuse my dear Aunt Sally, parentheses. Well, I don't have anything to do inside the parentheses. So the next thing would be exponents. I have an exponent in this one. It's not here. That 1/2 is going to stay exactly where it is. But 1/2 squared, I have to remember, oh, that means write 1/2 down twice and multiply it together. And when you multiply fractions, you multiply top times top, numerator times numerator, and bottom times bottom, denominator times denominator. So that's going to be 1/4. All right. So please excuse my dear multiply and divide. We don't have any of that. Aunt Sally, add and subtract. Yeah, we've got to add those. That's what's left. But when you add fractions, adding fractions is a little tougher than normal addition because you have to do what? You have to have a common denominator. So right now, I have 1/2 plus 1/4. What I need to do is look at my denominators and figure out, is one of them the least common denominator, or do I have to find another number that I could multiply the 2 and the 4 by and somehow make them the exact same thing? Because that's what a common denominator is. And I realize, oh, if I just multiply 2 times 2, it'll be 4. So 4 is the least common denominator. I just have to multiply this fraction by 2 on the top and the bottom, and then I'll have a common denominator. So this will be 2/4, which of course is 1/2. We haven't changed the value, we've just changed the way it looks. Instead of 1/2, it's now 2/4. And I still have to add that 1/4. But because I did that step, I now can put these two together because they have to have the same denominator, a common denominator. Common means the same. And now I can do the addition on the top because I know that 2 plus 1 is 3. So that's 3/4. Now we have the got it. And this one's a little tougher, but I want you to give it a try and use your, please excuse my dear Aunt Sally. Hit pause, see what happens. All right, so one of the most common mistakes on this one is that somebody writes down -2. That's not the answer. So let's see what happened here. If somebody got a -2, what did they do? 2 times 6 squared minus -3 squared. Now notice I use double parentheses. Whenever you put a negative in, when you substitute that into an expression, you should be using parentheses, especially if you're going to grab a calculator to do some of the math, which we don't want to do at this point. And that's all divided by 3. All right. Please excuse my dear Aunt Sally, parentheses. Oh, but there's some math I have to do inside the parentheses in order to do the problem. I need to do -3 squared and 6 squared. Now, why do I have to do those? Because I need them to just be numbers so I can do the parentheses. So 6 squared is 36. And then negative 3 squared is negative 3 times negative 3, and that's 9. Don't forget about the 2 out in front. Now, 36 minus 9 is 27. Now again, you could do a little bit of canceling at this point, or you could go ahead and multiply top times top and get 54 thirds, and then take 54 and divide it by 3 and get 18. Like I said, you could do some canceling right there. And that would leave you a 1 on the bottom. Canceling is a form of division, so you're dividing both the numerator and the denominator by 3. And then you'd have 2 times 9 is 18. Well, how would somebody get negative 2 on this problem? How did they manage that? Well, what happens is people forget to square the 6. So they put a little 6 up here in the place of 36. That's wrong, so we want to do that. But 6 minus 9 would be negative 3. You'd have 2 times negative 3 divided by 3, which is negative 2. Very common that that happens because people focus on, oh, I've got this negative that I have to raise to a power. And then B says, will the value of the expression change if the parentheses are removed? Oh, so if we did this, now I'd still need the set of parentheses around my negative 3 there. Would that change the answer? And the answer to that question is it absolutely would. Because remember, if there's a number outside of parentheses, it has to be distributed to both terms. So this 2 would need to go to both the 6 squared and the negative 3 squared in order to do that correctly. So, yes. And we can put distribution, because that's what would have to happen in order for those to be exactly the same. Problem 4. Now we're back to doing a little bit harder translation for problem 4. We're talking about ticket prices for admission to a museum. So ticket prices for admission to a museum are $8 for adults, $5 for children, and $6 for seniors. What algebraic expression models the total number of dollars collected in ticket sales? And this is where we're going to stop and come back tomorrow. And I'm not going to give you an assignment just yet. I think after we're done with the whole section, you can have the 1-3 assignment. So no assignment for tonight, but make sure you've taken really good notes and that you're taking a look at those objectives and saying, yep, I've got that. You know what? I got 18 when we did that evaluation problem. Like that. Piece of cake. So then rate yourself after the lesson. And that's everything for section 1-3, day 1.